we've learned three forms of the quadratic relation. We have standard form, y equals ax squared plus bx plus c. We have vertex form, and we have factored form. In this unit, we've looked at all three forms independently. That is, each is a different way to describe a quadratic. If I graphed any of these in Desmos, they would all give me the shape of a parabola. We have not talked, we will not test on how to move between forms. That's part of what we'll learn in the next unit. Each of the three forms, standard, vertex, and factored, gives us different information about the parabola. So I can't find out all the information I need from just one of the three forms. So for example, when we have standard form ax squared plus bx plus c, the only thing I know right away is a tells me the direction of opening. If a is positive, we open up. If a is negative, we open down. And c tells me the y-intercept, where the parabola crosses the y-axis. If we see a parabola in standard form, all we really know is the y-intercept, and then which way does this parabola open. So it's probably the least, I would say, useful of the three, and we'll kind of talk more about what's the point of standard form in the next unit. Vertex form, on the other hand, a x minus h in bracket squared plus k, that always tells us the vertex of the parabola, which is it's hk. The negative in the brackets should remind us that we need to flip the sign of h, and we'll do a couple examples where that becomes clear. We don't flip the sign of k, which is our optimal value, or the y-coordinate of the vertex. So vertex form is called vertex form because we should be able to read off the vertex without doing any math. We use the same letter a because it means the same thing. Which way does the parabola open? I've just got here in the note, h is the x-coordinate of the vertex. That's also that line through the middle of the parabola, that axis of symmetry. So the vertex is always located on the AOS. So if I know the vertex, I know the AOS. The third form, we call it factored form. We could call it zeros form, if that helps you remember it better. That the information I get in this form is I learn the two zeros r and s. So r0 and s0 is how we like to write our x-intercepts as points, and those are the two zeros or roots or x-intercepts. So I can read in the brackets these negatives are reminding us to flip the signs of r and s. The last point is that axis of symmetry. Because the parabola is symmetric, the two zeros are equal distant from the line through the middle, from the vertex or from the AOS. So if I want to find the axis of symmetry, that's the middle point between my two zeros, and to find a middle point in math or to find an average, I just need to add them up and divide by 2. So sometimes it's going to be easy just to count to the middle, but if they're larger numbers or decimals, we can use this formula to find the axis of symmetry. And again, a is telling us the same thing in factored form, which way does the parabola open. So depending on what I need to do, or depending on what information I'd like to find out, one of the forms may be more useful or more appropriate than the others. Let's do a couple examples, and again, if you have any more specific questions, please shoot me an email or log into one of our study halls. So in the first example, we're going to determine the vertex and the y-intercept of this parabola. Y equals 3x plus 2 squared minus 5. The first thing we always want to do when I see a parabola is figure out, well, what form is that? So it should come pretty quickly to us that that's vertex form, because I have one piece of key information, the h inside the brackets and the k outside. So my vertex is going to be h and k. I flip what's inside the bracket, so it becomes a -2, and I don't flip what's outside, so my vertex is -2, -5. If that flipping inside, what this really is showing is, remember our form or our pattern is x minus h. What this really is x minus -2. So that's why the h value is actually -2, so my vertex is -2, -5. My vertex is always h, k. The y-intercept is not told to us directly in the equation. I can't just read it off. I have to do a little bit of algebra. The one thing we know about a y-intercept is that it always occurs when x is 0. So it's always on the y-axis where there's no horizontal position left or right. So what I'm going to do to solve it is I'm going to sum 0 for x in my equation. So if I know x, I can always solve for y by replacing x with what we know its value is, in this case 0. And now I can follow BEDMAS. I'm going to do brackets first. Then I have to do my exponents. 2 squared is 4. I'll continue up here. 3 times 4 is 12 minus 5, or y is 7. So my y-intercept must be 0, 7. So I can always find the y-intercept by subbing in that we know the x-coordinate is always 0. And that works in any of my 3 forms. So that's an application of vertex form. I can just read the vertex off. I can find the y-intercept. I don't actually have the tools yet to find the zeros from vertex form. Common examples that we were doing in class, and I think that we all did on our 3 forms quiz, is that we had to determine the equation of a parabola. I'm going to do 2 questions like that. And again, you're welcome to pause the video and try to do these on your own. When we're determining the equation, we're picking which of the forms is going to work for us, which is going to be appropriate. First, we're trying to find the equation of a parabola where we know the vertex, 3, 1, and we know some other random point, 1, 13. I don't know the zeros, I don't know the x-intercepts, so I can't use factored form. I wouldn't have enough data or enough information to plug in. But I do know the vertex, which again we know is hk, so I can use vertex form, and we can find the equation. So whenever you're determining an equation, whether it's a line, a circle, or parabola, we want to start with our target and then sub in the information that we know. So first, I'm going to sub in 3, 1 from my vertex hk. When I say sub in, I replace every time I see h and k with the coordinates of the vertex, again flipping as I go into the brackets. So now I have an equation. I really need to solve for this parameter a. I need a number for a. So what I can do is I can take in any other point to sub in for x and y. So it's given in the question. I have this point 113, and I can sub that in for x and y. So I'm left with 13 in place of y. I still don't know a, but now I know x is 1. Because I don't have space to work vertically, I'm going to move up horizontally here. And again, I'm going to follow Bedman's to solve this equation for a. We're good at solving equations with only one variable or one unknown. 1 minus 3 is negative 2 squared. Anything in the bracket squared is going to be positive. Negative 2 times negative 2 is positive 4, so I have 4a plus 1. Be really careful following bed math between these 2 steps. I'll bring the 1 over. So 12 equals 4a, or a equals 3. Our last step, the question told us to determine the equation. So what that means is I'm going to rewrite my original equation, but now I have values for my parameters. I have values for a, I have a value for h, and I have a value for k. So there's my final answer. Any equation we work with in math that we can graph is always relating x to y, or inputs to outputs. So the only variables I want to see in my final answer are my x's and my y's. We'll do one more example like that. We're determining the equation of a parabola, but now we don't know the vertex. I can't use vertex form because I don't know what the vertex is. I don't know h and k. But remember that my x-intercepts and my zeros are r and s. So my target now, because I know the zeros, I can eventually, after a little bit of work, find my equation in factored form. So my first step is I'm going to sub in negative 3 and 4 for r and s. So I'm going to replace r and s with my 2 zeros. And remember, these negative signs should tell us that I'm flipping. So it's x minus negative 3. So it'll be x plus 3 and x minus 4. Again, I don't know a. I want to solve for a, but I do have some other point. In this case, that point's just a y-intercept. I actually know those coordinates, 0, negative 4. So I can sub in 0, negative 4 for xy. So negative 4 for the y. Still don't know a, but now I know x is 0, so I'm going to replace x with 0 in both brackets everywhere I see it. Continue on the right. And again, I've got to do what's in the brackets first. Now I'm multiplying everything together on the right side, so I have negative 4 equals negative 12a. So a equals negative 4 divided by negative 12, which reduces to positive 1/3. And again, my final step is just going to be an equation that relates x to y, but has no other parameters. Now I have values for everything. So it'll be x plus 3, x minus 4. Sorry, I'm getting a bit close to the edge there. So again, I've termed the equation, but this time I did factored form. So I think the takeaway from those two middle examples is if I have the vertex in any other point, I can always find an equation in vertex form. And when I have the zeros in any other point, I can find the equation in factored form. It's kind of analogous to when we worked with lines in grade 9. If you had the slope at any point, you could find the equation of the line. So you can kind of think of it as a similar idea. The last question is a little bit different. I'm actually giving you the equation. Again, your first question should be, hey, what form is that? And in this case, we know it's factored form because I have those two brackets. There's no squared. There's no number at the end outside the brackets. You should be able to really quickly recognize, is that factored form? Is that vertex form? And I want to determine all this key information, then we're going to put that onto a sketch. So the zeros should come quick. In factored form, I know my zeros. Remember, it's x minus r, so r must be negative 1. So my first zero is negative 1, 0. And my second zero, it's x minus s, so again, we flip. So my second zero is negative 9, 0. Okay, well, if I know my two zeros, I know my axis of symmetry is directly in between them. So you can either think to yourself, well, what's directly in between negative 1 and negative 9, and use a number line, or to find any middle point in math, we're just going to add up our ends and then divide by 2. So in this case, I've got negative 10 divided by 2. So I have my AOS, and the equation from AOS is always x equals negative 5. So it's a vertical line running through negative 5 on our graph. Yeah, come on in. Okay. Once we have our AOS, so far we found the zeros, we found the AOS. Our next task is to find the vertex. We know the vertex is always on the AOS. So the vertex is always directly in the middle of a parabola because it's symmetric. So to find the coordinates of the vertex, I already know one of the coordinates. I already know what x is. So to find the y coordinate, all I need to do is sub AOS to find vertex. So what I'm going to do is I'm going to sub in what we know is the x coordinate of the vertex back into our equation that was given to us in the problem. So negative 5 will replace x, and then I just need to follow BEDMAS to solve this equation for y. 2 times negative 4 is negative 8, times 4 is negative 32. I'm just multiplying three numbers. So now I know the coordinates of my vertex. It's negative 5, negative 32. So we have the vertex now. And the last thing is I want to find the y-intercept. And we know one thing that's always but true with the y-intercept, that x is going to equal 0 because it's on the y-axis. And again, I'm just using my original equation. So what we're using here, what we're relying on, that whenever I know an x value, the equation is kind of a map or a rule that shows me how to find the y value. So 2 times 1 times 9 is 18. So if I write that as a point, my y-intercept is 0, 18. The last thing that the question wants is me to sketch the parabola. So a sketch is not a graph. It's not like when we're working with the mapping rule where we can precisely find each point. Here I just want us to put the key information on the axes. So I'll just draw the axes on. And I'm going to take these 4 key pieces of information and use that to create a graph of the parabola. So the first thing we found out was my zeros were at negative 1, 0. So it's got to be on the left side of the y-axis and negative 9. Then I found the axis of symmetry was right in the middle, which was that vertical line at x equals 5. I could label that x equals negative 5. And then I found my vertex somewhere here. And again, a sketch doesn't have to be to scale. So that vertex is at minus 5, minus 32. And then the last thing I did is I found the y-intercept, which was 0, 18. And the nice thing about a sketch is it's a good way to check our answer. This does indeed look like a parabola that's symmetric. It looks like it's opening up, which we do because our a value is positive. And so my last step is to connect all those points was a smooth curve. Okay, and if I wanted, I could label those 2 zeros as well. So it's always good to kind of label the key points. Okay, so the idea of this last question is when I have a parabola in factored form with a little bit of algebra, I can find out all the key information I need to draw a pretty good sketch of this parabola. So that's a review.